Okay, let's have a look at this question. So it says a ladder 3 meters long, weight is 50 newtons, rests on a rough horizontal ground against a smooth wall. So let's just, there's the ladder, there's the wall, and this is rough, and this is smooth. Okay, there's the wall. Now, so basically, there's a point there, there's a point here. So smooth wall, ladder is modeled as uniform, so the weight is going to be in the center, coming down, and that's going to be 50 newtons. Now that is 3 meters, so that will be 1.5 here and 1.5 here. They said it's a rough ground, so that's stopping it from slipping is friction going that way. Okay, and this is the contact force perpendicular to this ground, call that Rn. Okay, and this is the reaction force from the wall. Okay, so that's from the ground, this is reaction from the wall. Okay, let's call that W. Okay, right, actually I don't like calling it W because that could get confused with weight, so let's just call that N, reaction from the wall, and this we call reaction from the ground. Okay, so far so good, that's smooth. There's nothing going down here, there's no friction along here, so it's all smooth, uniform. The angle theta it makes with the horizontal ground, so that is theta. Okay, coefficient friction between the ladder and the ground, so mu is going to be 0.8. A boy of weight 400 newtons stands on the ladder, at the top of the ladder. So let's just put this boy is going to be topping at the top of the ladder. So okay, so it says at the top, so I'm going to put him right at the top. Let's just be precise. That's the reaction from there. So he's right at the top. So there's that's going to be of 400 newtons. Okay. Given that the ladder is on the point of slipping, when it's on the point of slipping, friction is at its maximum. So friction is mu times Rn, which is here. Okay, it's about to slip. Okay, so that's maximum. So that friction is going to be 0.8 Rn. So let's start filling in what we know here. So basically we've got forces going upwards, forces going down. So Rn is up, and because it's about to slip, it's in equilibrium, so it's balancing with this 50 going down this way. So I'm just showing the arrows, which I should do that in different colors. So we got this arrow going up, this is going down, and this is going down. There's nothing, so we're doing it vertically, so that will be 50 plus the 400, so that's be 450. So friction is going to be 0.8 times 450, because Rn is 450. Okay, we just got to break this down. So 0.8 times 450, we get 360. So that's what friction is, 360 newtons. Now, so friction is, again, I'm going to put some different color arrows. Let's put green. Friction is acting this way. So what is going in the opposite direction is the reaction force. So friction is going to be N, reaction force from the wall. So N and F, friction is 360 newtons. Okay, and we need to find theta. Now, what else do we know? So we've got all those. let's have a look. What else do we know? Let's take the moment. Let's take the moment about this point. So from this point, we've got the weight of the ladder going down, and we've got the weight of the boy going down this way. So this is called the clockwise version. And what we got, this force is going to be going all the way along here. So it's going this way, and this is going to be going anti-clockwise. And because it's still in equilibrium, so any force is going through this point, okay, the moment at, let's call this A. So at A, all the forces going through A don't count, because the distance, perpendicular distance to that force is 0. Okay, so let's take the moment at A. So this perpendicular distance to this weight is going to be, that's a hypotenuse, and this is the cosine. So this will be cos 1.5 cos theta. Okay, plus, now this distance is 3, and that's angle theta. This is cos theta, so that's going to be 3 cos theta. And that is balancing. Okay, oh yeah, sorry, done a mistake here, sorry, let's go back. So it's always, that is the distance. What I haven't done is multiplied it. I must multiply that by the weight, which is 50, the force. And the one that I had before was 3 cos theta. That is the distance, 3 cos theta, because it's 3, that's the hypotenuse, times cos theta. And that's going to be multiplied by the weight, which is 400. Okay, now because it's about to slip, which means it's maximum friction, it's about to slip, I mean still in equilibrium, it hasn't slipped, so that will equal, so this was called the clockwise, will equal the anti-clockwise. Now this distance here is the same as this distance here, okay, which is going to be opposite, 3 hypotenuse times sine theta, so 3 sine theta, and that's going to be multiplied by n, which we know is 360 here. Okay, so let's just calculate all this. So actually I'm going to put a semicolon. So that's going to be 1.5, just quickly do that, 1.5 times 50 and 400 times 3. And that's going to equal to 1275 cos theta. Okay, and that's going to equal to, now we know that n is 360, so that's going to be 360 times 3, so that's going to be 1080 newtons sine theta. So if I take this to that side and this number to the other side, so I'll get 1275 shared by 1080, and that will equal sine theta over cos theta. So I literally divided 1080 on the left hand side, and on the right hand side I've divided it by cos in order to give me a tan function, and therefore theta will equal tan inverse of this, which is, I'm going to now just do that on my calculator. So tan inverse 1275 over 1080, and that's going to give me to, it doesn't say but always give it to 3 zero figures, 49.7